In this question, we're going to graph the curve y equals x minus 2 quantity to the 4/5. Well, we start by looking for the y-intercept. So we're going to let x equal 0. So letting x equal 0, we have a -2 quantity to the 4/5. Now, when considering a negative value to a fractional exponent, think of the denominator first. Deal with that. So we're going to consider if -2 quantity to the 1/5 exists. Well, in fact, it does. It's possible to have the fifth root of a negative number. A number times itself 5 times can be negative. And so, in fact, we have a negative quantity here. -2 to the exponent 1/5 is negative. But then we raise that to the exponent 4. A negative value raised to the exponent 4 is a positive number, and in this case our y value is approximately 1.74. Now we're going to consider our x-intercept. Our x-intercept occurs where y equals 0. Well, if 0 is equal to x minus 2 to the 4/5, then that means x minus 2 is 0. 0 to the 4/5 is 0. So x minus 2 would be 0, which means x would be 2. Well, we have no vertical asymptotes, horizontal asymptotes, oblique asymptotes, or holes. We have a denominator of 1, so none of these factors come into play. Now let's consider our derivatives. Y equaling x minus 2 quantity to the 4/5 means y prime is 4/5 x minus 2 to the -1/5 times 1, the derivative of the interior of that bracket. 4 is in the numerator, 5 is in the denominator, x minus 2 to the 1/5 is in the denominator. Well, we see that that first derivative can't equal 0 because the numerator can't equal 0. But the denominator can equal 0. The denominator equals 0 when x equals 2. So y prime is undefined when x equals 2. Now at this point, note that y prime is undefined when x equals 2, but y is defined when x equals 2. When x equals 2, y is 0. So when you have a situation where the y value is defined at a given x value, but the derivative is undefined, right away we think to ourselves, well, we might have a cusp or a vertical tangent. Because y is defined when x equals 2, but y prime is not defined when x equals 2, we might have a cusp or a vertical tangent. It's worth thinking about, keeping that in the back of our mind. Well, y prime is 4/5 x minus 2 to the -1/5. We're going to determine the derivative of that. In other words, get the second derivative. We have -4/25 x minus 2 to the -6/5 times 1, which is the derivative of x minus 2. So we'll have -4 in the numerator and 25 in the denominator. X minus 2 to the +6/5 will be in the denominator. Now, just like we did before, to think about x minus 2 to the 6/5, let's think of x minus 2 to the 1/5 and then raise that to the exponent 6. So just like we did last time, let's think about the denominator and then put the numerator on the outside. We see that y prime prime can never equal 0 because the numerator is -4, and y prime prime will be undefined when x equals 2. When x equals 2, that denominator will equal 0, so y prime prime will be undefined. So we have y prime equaling 5 times x minus 2 to the 5th, and y prime prime equaling -4/25 times x minus 2 quantity to the 1/5 raised to the exponent 6. Now, when x is a number less than 2, y prime will have a positive numerator, and x minus 2 will be negative. A negative number raised to the 1/5 will be negative. So we'll have 4/5 times a negative, which is negative. When x is greater than 2, x minus 2 will be a positive quantity. A positive quantity raised to the exponent 1/5 is positive. 4/5 times a positive will be positive. Now let's look at y prime prime. Suppose x is a number less than 2. X minus 2 will be negative. A negative number raised to the exponent 1/5 is negative because it's possible to take the fifth root of a negative number. It's possible to take the odd root of a negative. So when x is less than 2, x minus 2 to the 1/5 will be a negative number. but raising that to the exponent 6 will make it positive. 25 times a positive will be positive, so we'll have a negative over a positive, which is negative. Now, when x is greater than 2, x minus 2 will be positive. The fifth root of a positive number is positive. Raised to the exponent 6 is positive. 25 times a positive is positive. So we'll have a negative over a positive, which is negative. So you don't need a calculator for that stuff. So, in summary, we've got an x-intercept at approximately 0.174, a y-intercept at approximately 0 and then 1.74, and an x-intercept at 2, 0. And in our mind, we're saying, hey, we might have a cusp or vertical tangent there. Let's see what happens. And this is what's happening with our increasing, decreasing, and concavity. Well, what we do is we have our x-intercept here, our y-intercept here. We have a function that's decreasing and concave down to the left of 2. So that means the curve looks something like this. It's decreasing and concave down. In other words, the curve is below the tangent line. Then to the right of 2, it's increasing and concave down. And that kind of makes sense. And we see that this is increasing concave down because it's certainly increasing, and it's concave down because the curve is below the tangent lines. And so this is what the curve is. It's defined at all real numbers. At x equals 2, we have a cusp. The first derivative is undefined, and we can see that kind of makes sense because it would be hard to choose one particular tangent line to say what the exact slope is there. So this is the curve y equals x minus 2 to the exponent 4/5.